Hello, I am Dairi, a master degree in DTM lab of Department of Industrial System Engineering of Dongguk University. And today I start the paper review. This is the bibliographic information. This study published on 2023 in the Journal of Technological Forecasting and Social Change. And this is the keyword and highlight in this study. The content is as follows. First, I explain the research background and research purpose. The recent emergence and development of new technologies have had a significant impact on global economic and social development and are even changing people's lifestyles. Companies invest huge budgets to support technological innovation, and identifying technological opportunities is the starting point of these R&D activities. Technology opportunities are the information needed for strategic decision making to adapt to market competition, technological innovation, and social change. And previous studies have mainly relied on qualitative analysis methods such as DELPI and morphological analysis, but these are largely dependent on the subjective judgment of experts, which may result in biased research. In the era of big data, it is difficult to effectively identify technological opportunities based on simple expert judgment alone, as vast amounts of technical information must be analyzed in scientific papers and patents. Most existing studies use keyword analysis, text mining, and citation network clustering to identify macro level technological opportunities at the level of technology trends. Keyword analysis methods do not properly reflect the semantic relationships of text and mainly identify technology opportunities only at the level of technology problems. Emerging technologies are often overlooked because knowledge is not sufficiently accumulated and thus are not included in cluster formation. So, this study proposes a framework that comprehensively identifies technology opportunities at both levels of technology problems and solution by combining SAO, semantic analysis, and outlier detection methods. And I explained about the literature review. First, the gaps between science and technology analysis for identifying technology opportunity. Science is considered the seed of technological innovation, and companies use it to develop and industrialize technologies. Linear models of innovation fail to adequately reflect the complex interactions and feedback loops between science and technology. So, science and technology are interdependent, but a gap exists due to the lack of connection between scientists and business. And technical topics that exist in scientific papers but do not appear in patents may be considered technological opportunity. Existing studies mainly identify technological opportunity by comparing scientific papers and patent data through clustering and text mining. However, they are insufficient in identifying emerging technologies but by not including outlier. Next, I explained about SAO, semantic mining. The SAO structure consists of a subject, an action, and an object and expresses the relationship between technology function, problem solution, and technology components. The SAO structure effectively reflects important technical information in the text and can automatically extract semantic relationships. research is being conducted to create a technology roadmap or analyze technology evolution trends using the SAO structure, but most study only use the SAO structure for clustering and do not perform in-depth analysis of semantic relationships. Next, I explained about outlier detection. Outliers are observations that deviate significantly from the data set and may indicate new technologies or technology trends. Disting- and distinguish between local and global detection methods. The in this study, it uses three main algorithms. First, KNN, that is detected outlier by calculating the distance between a point and its neighbors. Second, ROF is detecting outliers based on density and considers points with low density as outliers. Last, isolation first is detecting outliers through a split tree structure and has high computational efficiency. So, isolated papers or patents may represent novel technologies that are distinct from existing technologies. So, existing studies mainly rely on either local or global detection, and studies that integrate both approaches are lacking. And I ex- and that is major limitation of previous studies. First, cluster-centric analysis in the gap analysis between science and technology overlooks isolated points. For example, papers or patents. Next, lack of in-depth semantic analysis of the essay structure which fails to identify technology opportunities that encompass both technology problems and solution. Last, reliance on single algorithm in outlier detection limits the competence of the result. So for for the erase the limitation and has contributions of this study. This study has three contributions of this study. First, combining clustering and outlier information to more fully identify technology opportunities, and in-depth analysis of problem solution and technology function relationships in the SAO structure to improve the accuracy of technology opportunities. Last, three, integrated use of scientific papers and patent data to drive technology opportunities at the level of technology problems and solutions. And I explained the methodology about this study. First, this study proposes a research framework that combines SAO, semantic analysis, and outlier detection method to deeply analyze the relationship between science and technology and identify technological opportunities. And it identifies technological problems and solutions at two levels using scientific papers and paper patent data as primary resources. So the entire process consists of four steps is as below. And I explain the process in more detail. First, data collection and pre-processing. It collect data using WOS and DIDB as data resources and download related paper and patents using a search query related to the research topic. After that, it removes noise data, converts the preprocessed data into a format suitable for text mining, and then divides the reprocess data by year. And next, extracting technical topics from scientific papers and patents using SAO semantic mining. First, it automatically extracts SAO structures from papers and patent abstract using Stanford Core NLP. Next, the semantic relationship of the SAO structure is calculated using a WordNet-based similarity algorithm, and the text similarity between papers and patents is calculated. Next, it visualizes paper and patent data in two dimensions using multidimensional scaling, and it identifies technical issues and technical solutions through clustering. Next, with the help of the group of experts, it constructs a technology tree for TENG and systematically organizes the relationships between technical problems and solutions. Third, detecting outliers in scientific papers using outlier detection method. This study uses the three main outlier detection algorithm, so it detects outlier in each year's paper data using KNN, LF, and IF. The intersection of the three algorithm research is considered the final outlier, and it compare outlier paper topics with patent topics to determine whether there are new technological problems on our solutions. Lastly, um, the identifying technology opportunities using the analysis of gaps between science and technology. It identifies solutions that have been repeated in scientific papers for more than 2 years but not reflected in patents as technology opportunities. And it identifies unique technology opportunities by analyzing the deeper differences between outlier paper topics and patent topics. Next, I explain the case study in this study. The research subject is a triboelectric nanogenerator, a technology that generates electricity from human movement, etc. It is a technology that has the potential to bring about great changes to the energy industry, so it is important to identify related technology opportunities. As a technology that has the potential to bring about significant changes to the energy industry, it is important to identify related technology opportunity. Accordingly, 2,204 papers related to TENG were collected from the WOS, and 174 patents were collected from the DI. After that, the data was organized by year and preprocessed into a format suitable for text mining. Next, it made clustering of scientific papers and patents. Um, it make clustering scientific papers and patents using the SAO structure and deriving each as a primary technique. And um, the result of identifying primarily technical topics, scientific papers has nine primary technical topics derived, and patents have 8 primary technical topics. In conclusion, a total of 10 major technical topic was derived, and the result is about table 1. Next, based on the primary technology topic, the TENG technology tree is constructed to systematize the relationship between technology problems and solutions. The technology tree is divided into five categories: energy source, application, material, structure, and hybrid energy. And to make in-depth analysis of the essay structure within the first technical topic to derive technical solutions as second technical topics, um, that examples is as below. And Rust. Some secondary technology topics have been repeated in scientific papers for more than 2 years but are not reflected in patents. These are considered technology opportunities. Examples include human body movement, energy harvesting, and self power tracking systems. The figure 5 and table 2 below classify technologies into four types based on the intensity and meditation of technological convergence and visually show the result of driving major convergence technologies and technologies with the high possibility of meditating convergence. Next, the analysis of the scientific papers related to TENG using outlier detection method. First, using KNN, LF, and IF, this study referenced outlier in scientific paper data from 2030 to 2090 and considered the intersection of the three algorithm results as outliers. As a result, some outliers are developing into new solutions to existing technical problems or indicating new technical problems. Next, it identified new technology opportunities by comparing outlier paper topics to patent topic, and the paper numbers and the topic of outlier scientific paper is indicated in the table 3. And the result of the manufacturing service technology convergence network analysis from 2011 to 2014 about period 2. The main service technology include this code, and the main manufacturing technologies include this code, and quantitatively shows the frequency of convergence of technologies and their importance in convergence through connection centrality and between centrality. Next, this is a multidimensional matrix and network visualization that data that visually express the analysis result for discovering the promising manufacturing service convergence technologies. So I explained about one example for topic 3. It visualized the promising convergence technology network, which visually shows the technology network that includes major service technologies and manufacturing technologies. And the size of the nodes indicated the frequency of the technology, and the thickness of the edge indicate the intensity of convergence between technologies. But I um, I can't edit the figure about the visualizing outlier detection method, but I explain the more figure about this study in the time that paper review study study and um, it table and the table 5 is the summary of the results of the manufacturing services technology convergence network analysis in period 3. from 1215 to 1218. And this CPC code were identified as a major services technology, and these CPC code were identified as major manufacturing technologies, and indicating that the frequency and diversity of technology convergence significantly increased compared to period 2. In addition, a group of experts conducted a final verification of the identified technological opportunities based on technology development potential and economic feasibility. Last, I explained about conclusions. The research purpose is to two purpose. First, integrated analysis of scientific papers and patent data to identify technological opportunities in the gap between science and technology and at an early stage. And it purpose of framework data comprehensively identifies technological opportunities at both the level of technological problems and solutions by combining SAO semantic analysis and outlier detection methods. This study this study have contribution research based on the purpose. It helps understand the interactions and evolutionary paths between science and technology, and it provides in-depth analysis of technology opportunities, including both technology challenges and solutions. Lastly, it provides critical information for government R&D strategies, corporate investment, and policy decisions. But the study have limitations of the study and future task. First, limitations of data resources. Mm, it relies solely on WOS and DI databases. It does not reflect market information or user needs. So, future research needs to identify technology opportunities more specifically through analysis that includes market information and user data. Next, extension of SAO structure. This study only analyzed the technology function problem solution and inclusion relationship in the SAO structure, but future studies plan to analyze richer semantic relationship and conduct in-depth technical text mining. So I ended the paper review. Thank you.